Hello, today we'll be seeing delegates and events. This is the third experiment in C Sharp lab, C Sharp and .NET lab. So today we'll be using matrix elements to add, to subtract, and then we have array of delegates, multicast delegates, anonymous methods, Lambda expression to multiply, to add 5 to the matrix object, and then we have event. So basically we'll directly go into the program and see how delegates and events work. So this is the program that we have for matrix operations. Basically delegates in C# are very similar to the pointers that we use in C and C++. These are actually using programs to encapsulate a reference to a method inside a delegate object. So basically there are 4 main things required in any delegate. First is the delegate declaration, second is the delegate method definition, third is delegate instance creation, fourth is delegate invocation. So the first thing that we are supposed to do is declare. So to declare we have the keyword delegate and followed by the return type in case if it is void or int anything, followed by the name of the delegate and the braces, the curly the brackets, and then we have inside it in case you have any signatures. In case we have signatures for every function that we will be declaring, that we will be defining under the delegate should have the similar signature type. So here I am not using any signature. In case you have, we can. So basically this first method is declaration. Second, I have the class in which I'll be doing all my operations, like the functions which I'll be declaring all my functions. So I have public class matrix, the matrix class. This is for event, this basic thing. We'll do the delegate part first. So I have public matrix. It's in constructor which takes in 2 arguments, 2 arrays basically, which I have declared here, A and B. I am initializing it to 2 cross 2 and keeping it short. We can declare it to more if we want. Then we have the toString function if I want. And then I have the add matrix, and here I'm just taking the matrix which I have A and B and I'm performing operation on that. A plus B is equal to C of I. I'm taking a new array matrix that is C, 2D, in which I'll be storing my matrix C. Same I do it for subtraction of matrix, and then this is for matrix operation which we'll be looking into. So into the main class I have my matrix test class, in which again I'm taking two matrix which I'll be asking, taking the input using the readline int.pass console.readline. Then I'll be passing these 2 to the matrix object M that I have created, in which I'll be performing my operations. So that is how it is. So the first thing that we are going to do is to create a delegate and to invoke a function of to add matrix and to subtract matrix. So basically the case 1 I'm taking switch. So case 1 is using the delegate name, that is nat of OP. Matrix 1, the delegate name will be is equal to new, I'm using a new operator of the delegate, in which the function will be from the class matrix of the object M dot add matrix. We notice here that we do not put these braces, we simply have it inside the name. So this is how we invoke the addition matrix. The same I do it for subtraction. So let's see how addition and subtraction works. So exactly. So I'm going to enter a matrix. This is my matrix A. Matrix B will be my 4, 4, 4. So I want to add. So my resultant matrix will be 5, 5, 5, 5, 5. So this is how it is. So this was addition. The similar way the subtraction is also done. So if I give 5, 5, 5, 5, you can see the resultant matrix 5 minus 7 is minus 2, and then 5 minus 8 is minus 3, 5 minus 9 is minus 4, and 5 minus 4 is 1. So this is subtraction matrix. So basically what we did was to declare a matrix and then to define the delegate. First to declare that define the declaration part of the delegate, then to define the functions that will be in the delegate, and then to instantiate, that is using the new operator, the delegate name, the delegate name and the name which you're going to give, the new and then the delegate name and the function that's supposed to be involved, and then we invoke it simply using matrix 1, the name and the function, the way we call the function, simply it is invoked. So this was a simple delegate. Now for array of delegates, that's a third case, we simply have the name of the delegate that we have declared and the array format, and the operations will be written in the form of the same way how we declare and predefined array, that is m dot mat add mat comma m dot subtract mat, and then the curly braces close, and then we put a terminator. And because it's an array, we use a for loop. So int I is equal to 0, I less than operation dot length, that is the name of the array of delegate I'm using, and then I plus plus. So inside it I have using operation of the index I plus 1, that is 1. Instead of 0 and 1, it's just 1 and 2. So we call the operation of I the same way the function type, and we do it. So let's see how the array of delegates run. I enter a matrix, and then I go for array of matrix. We can see that using operation 1, the resultant array is adding 8 plus 5, 13, and 9 plus 7 is 16, and so on. And using the subtraction, it is 3. 8 minus 5 is 3, and then 9 minus 5 is 9 minus 7 is 2, so on. So this was array of delegates. Now for multicast of delegates, that's the next option. We have different ways, that's overloading, basically multitasking the operator. So we have, first of all, we are having the name, that is delegate, and then the name of the delegate is equal to m dot add mat. First I am inserting m dot add mat in operations, then using the plus is equal to operator, I am adding m dot sub mat also in operations. So through this way I can directly call operations then, or else I can have two variables of the delegate which stores first m dot add mat or m dot subtract mat, then I have operations which will be adding operation 1 and operation 2, and then we will be calling the operation. So this is multicasting, delegate multicasting. So let's input the array. So we can see number 4, multicasting of array. So we can have that if we add, it is 5 plus 4 is 9, and 7 plus 3 is 10. If we subtract, it's 1 4 1 4. So this was multicasting of delegates. Now let's move on to anonymous method. Anonymous method, here we are not having any particular, we are not using new operator to create and all. We are simply just going to use the delegate name, and the delegate is equal to the delegate. That is the delegate thing which you have declared the name of the delegate as mat, and the name that you are going to give to the function that will be anonymous math operation, that is equal to delegate. So inside that delegate function, I am having I'm going to basically multiply every element of one array that I'm going to input. Basically it's the first array that I'm going to input and multiply it into 2. I'm multiplying every element by 2. So the resultant array will be shown, and basically I'm just calling it anonymous mat array and then using the function for it. So let's see how anonymous work. Matrix A, let's give it as 2 2 2 2. Matrix B. Basically the operation will be done in the first array. So let's go for anonymous method. We can see the first matrix was 2 2 2 2 2. So when we multiply, it's just 4, 4, 4, 4, 4. So this was anonymous method using delegates. Let's move on to lambda expression. For lambda expression, that's case 6. So what we are here going to do is just add 5 to every element of the first array. So how lambda expression is used is the only difference between anonymous and the lambda one is here we are using the delegate. Here we are not. We are using this expression is equal to and greater than for the lambda expression. This is the lambda expression. So basically here inside this parenthesis, in case we have any signature value, that the arguments that we have declared for the delegate, we will be using it here. In case not, we just leave the parenthesis empty. So this basically, this structure is the lambda expression. So all we are doing is the same operation again. We are adding 5 to every element found, and then we are calling anonymous. Instead of anonymous, we can have lambda. So let's see how lambda expression runs. I'm going to input as 5, 5, 5, 5. There's an error in giving the input. So we'll continue. It is 5. So I'm going to go for lambda expression. The resultant array is 10. So 5 plus 5 is equal to 10. 5 plus 5 is equal to 10, 10, 10, 10, 10. This was lambda expression. Now we move on to events. Events again uses delegates. Events are nothing but which enables a class or object to notify other class or objects when something happens, when a condition is satisfied or fulfilled, or when you want to call it for some purpose, an event is taken in. So event is called. So for event we have again 5 major things. First thing is to have a delegate method definition, that is the event handler method, that is also known as the event handler method. So this is directly, indirectly the declaration method, the definition, and then we have the event handler method which we are declaring it here using event and followed by the delegate name and the event handler name. So it's event, the keyword, then the name that you are given to the delegate followed by the name of the event that you want to give. Then we have the delegate declaration. Here one more change here will be in the matrix constructor. I'm having, whenever this is called, I have this dot my event, that will be my matrix object. The delegate function will be plus is equal to new of mat operation, that is the delegate, is equal to this dot mat op. My mat op is the function here in which I'm checking if all the elements are 0. In case if they are 0, I'm taking it as invalid. In case if they are not 0, then the matrix is valid. To check that, I'm using a for loop. If a of ij is equal to 0, I take them as continue. Else, if there is even one element, 1 or 2, anything, the status will be true. So if the status is false, that is initialized first, which will be continued if it is 0, then the matrix is invalid. In case if it is true, that's the else, it is valid. So this is the major function, that is mat op is the event declaration part. So and delegate declaration part, the function. So to declare an event, we come down here. We are creating an object, a new object in which we are giving both the things, and then using the object name I call the function. So this will basically, when it is created, call this event, and then when this event is called, this takes us to mat op. So it will come down to here to execute this part. So this is basically the event invocation. So let's see how events work. So I'm going to enter a matrix. Let's take it as first. Valid matrix because all the elements in the matrix are valid. So this is delegates and events. Thank you for watching.